This video explains how to multiply and divide rational expressions. And I'll put a link up here in the upper right-hand corner for a previous video I did on simplifying rational expressions. So a rational expression is a fraction where the numerator is a polynomial and the denominator is a polynomial. All right, so let's first look at multiplying rational expressions. So it says, what is the product? State any excluded values. All right, remember when you multiply fractions, you just multiply straight across. Numerator times numerator and denominator times denominator. So 6 times -2 is -12. And then remember, a power times a power with the same base, you add the exponents. So that would be a to the 5th. And as far as excluded values, so first of all, that is the answer. You can't do anything else with that. As far as excluded values, those are values that would cause the denominator to be 0. And so in this case, a can't be 0 because 0 to the 5th would be 0, and a fraction with a denominator of 0 is undefined. So the excluded value in this one would be a cannot be equal to 0. Pretty simple, right? All right, so let's look at another one. X minus 7 times x minus 5. We're actually just going to leave it like that in its factored form because in algebra we considered that to be simplified as opposed to multiplying this together and ending up with a trinomial. So we're going to leave it that way, and then we're going to multiply x times x plus 3. We can't simplify this. There's no common factors here. So that's actually our answer. And as far as excluded values go, x can't be equal to 0 because that would cause the denominator to be 0. And x can't be equal to -3. That's -3 plus 3 would cause it to be 0. Again, pretty simple so far. Of course, you know it'll get harder. So one more of these easy ones. So x times x plus 1 over x minus 2 times x minus 3. Again, there are no common factors that can cancel out. So we're done. And the exclusions are x can't be equal to 2 and x can't be equal to 3 because those would cause the denominator to be 0. All right, so let's kick it up a notch. All right, what if it's not already factored? So those last couple problems we did were already factored. So if it's not already factored, then we want to factor them before we multiply them together. So x plus 5, we can't do anything else with that, so I'm just going to rewrite that. 7x minus 21, you can factor out a 7. So I'm going to rewrite that as 7 times x minus 3. 14x, I can't do anything with that. And then this is a trinomial. I'm looking for two numbers that multiply to -10 and add to 3. So that would be 5 and 2. And the 5 would be positive and the 2 would be negative. So x plus 5 times x minus 2. So 5 times -2 is -10. 5 plus -2 is +3. Okay, so let's go ahead and multiply this together. So I have 14x times x plus 5. And in the denominator, I have 7 times x minus 3 times x plus 5 times x minus 2. And now we look to see if we can simplify this in any way, and we can. So the first thing I see is the 14 and the 7 can be simplified to 1 and 2. And then the x plus 5 over x plus 5, that's 1. So those are going to cancel out. And so what I'm going to end up with here is, don't forget this x is still here. So I'm going to end up with 2x in the numerator over x minus 3 times x minus 2. There's nothing else I can do with this. So I'm done. All right, so if it's not factored, you want to factor it and then simplify it. So let's look at another one of those. So 2m plus 5, I can't do anything with that. No common factors except for 1. 3m minus 6, I can factor out a 3. That gives me m minus 2. And whenever you multiply a fraction times a whole number, I know this isn't a whole number, it's a trinomial, but remember what you would do is just put that over 1. So that's what we're going to do. And then we're going to factor this to numbers that multiply to negative 6 and add to positive 1. So that would be positive 3 and negative 2. So m plus 3 times m minus 2. Now we can put this together. We get 2m plus 5 times m plus 3 times m minus 2. And that's all over. That's a beautiful straight line, huh? 3 times m minus 2. So the m minus 2's I can cancel out. So let's cancel those out. The 3 has nothing that I can cancel it with, so I can't do anything else. So our answer is going to be 2m plus 5 times m plus 3 over 3. And there we go. All right, so that's examples where you have to factor first and then simplify. So what else do I have? Dividing. So if you've done, excuse me, dividing fractions, division of fractions, the way that I teach that with my students is I use this acronym KCF, which stands for, K stands for keep, the C stands for change, and the F stands for flip. So the way that you divide fractions is you actually multiply by the reciprocal. So you keep the first fraction, you change that to multiplication, and then you flip the second fraction over, which is called the reciprocal. So that's what we're going to do here. So let's get started. So I'm going to keep the first fraction. So it's going to be x squared minus 25 over 4x plus 28. Now I'm going to change that to multiplication, and I'm going to flip this over. X squared plus 9x plus 14 over x minus 5. And now I'm going to start factoring. So hopefully you notice that x squared minus 25 is a difference of squares. So that can be factored to x plus 5 times x minus 5. In the denominator, I can factor out a 4. So I have 4 times x plus 7. Let's move over to the next one now. Two numbers that multiply to 14 and add to 9. That would be 7 and 2. So x plus 7 times x plus 2 over x minus 5. And I'm actually going to go ahead and simplify it here before I put them together just to save space. And that's totally fine to do. If I was doing this on my own, this is how I would do it. So this x minus 5 will cancel with that x minus 5. This x plus 7 will cancel out that x plus 7. There's nothing else that I can simplify here. So now I'm just going to put it together. So in the numerator, I have left an x plus 5 times an x plus 2 divided by 4. And there's nothing else you can simplify. All right, so when you have division, you're just going to change it to multiplication by multiplying by the reciprocal. All right, so on this next one, I want you to keep in mind again that you can make this a fraction by putting it over 1, right? So now we're going to keep, change, flip. So we're going to multiply by the reciprocal. So let's rewrite this. Move this down, give us some room. So I have 3x squared minus 12x divided by 5x times 1 over x squared minus 3x minus 4. Let's factor this. All right, so in the top, I can factor out a 3. This kind of looks like a difference of squares, but square 12 is not a perfect square. Actually, I can factor out a 3x. So let's see. Excuse me. I'm sorry. Hopefully I didn't blow out your eardrums. So divide out a 3x. That leaves me with x minus 4. Can't do anything with the 5x, so I'll leave that there. Times 1 over two numbers that multiply to negative 4 and add to negative 3. So that would be negative 4 and 1. So x minus 4 times x plus 1. All right, let's see what we can simplify here, what we can cancel out. So I have an x minus 4 and an x minus 4. Is there anything else I can do here? Let's see, I feel like there's something I'm missing. All right, so yeah, I can factor, actually not factor, but I can cancel out these x's. So x over x is 1, so those are going to cancel out. And so what I'm left with, let's put this all together. In the numerator, I have 3, and that's it, just the 3 and the 1. And in the denominator, I have 5 times x plus 1. And there we go. All right, I think I got one more thing for you. Let's look. Complex fractions. So this looks worse than it is. A complex fraction is a fraction where the numerator and the denominator are each fractions. So it's a fraction over a fraction. But what you have to keep in mind is that a fraction is just another way of showing division. So if I had 3 over 4, that's the same thing as 3 divided by 4. So a over b divided by c over d is the same thing as a over b divided by c over d. So it becomes a problem like we were just doing on the last slide. So this can be rewritten as, move it this way, this can be rewritten as 1 over x minus 2 divided by x plus 3 over x squared minus 4. And then we're going to do keep, change, flip. So we're going to keep this 1 over x minus 2, change that to multiplication, take the reciprocal of this one, x squared minus 4 over x plus 3. X squared minus 4 is actually a difference of squares, so let's go ahead and factor that. So now I have 1 over x minus 2 times x plus 2 times x minus 2 over x plus 3. What can we cancel out? We can cancel out x minus 2. And so what we're left with is x plus 2 in the numerator over x plus 3 in the denominator. And there you go. So complex fraction, you just want to rewrite it as a division problem. So we would rewrite this as 1 over q plus 4 divided by 2q squared over 2q plus 8. Let's do keep, change, flip, and rewrite it as a multiplication problem. So 1 over q plus 4 times 2q plus 8, excuse me, over 2q squared. 2q plus 8 I can factor, so now I have 1 over q plus 4 times 2 times q plus 4 all over 2q squared. All right, let's see what we can do to simplify this. So these q plus 4s will cancel each other out. The 2's will cancel each other out. 2 over 2 is 1. And so I'm simply left with 1 over q squared. And there you go. All right, so that's multiplying and dividing rational expressions. Hopefully that was helpful and useful to you. If so, give it a like and a subscribe, and feel free to leave me a comment. Until next time.